So today I will be presenting on why the buildings are important to the grid. So first of all, moving to basics. The main question and the final goal is obviously to reduce global warming by reducing emission. And we know that for now, the world is still far from putting emission into decline. That is roughly the scenario if we continue in business as usual, and that is where we want to go. So as you see, huge difference. There has been an announcement that will help make the difference. For instance, that would be the impact of the full implementation of 2050 net zero pledge by countries that have such pledge. China net zero statement by 2060 would bring that more, but we still need a lot more than these two pledges to reach a sustainable development scenario. And we might want to go even further and to reach net zero. That would mean even more work to work, more renewable system, less carbonated energy. So we have a big challenge ahead of us. And to tackle this challenge, the IEA proposed highlighted a pathway towards this net zero 2050. So don't worry, I'm not going to mention all the measures needed to reach a net zero. I will just point two things to your attention. One is the growing importance of electrification. You will see that many measures relate to banning ICE car and so making car electric. You will see also measures around heat pumps that also mean exiting heating from fossil fuels. And last point I would like to attract your attention on is the milestone on building. You will see that in 2030, all new buildings are zero carbon ready. You will see that in 2050, 85% of buildings are zero carbon ready. And one interesting thing is that when the IEA talks about the zero carbon ready building, it talks, of course, of an efficient building. It talks of a building that has solar panels or other resources when possible, but it's also a connected building, a building that is smart and data-driven. And that's part of going toward net zero, and we'll see more why this is important and why these smart buildings are needed to reach net zero. So taking a step back to how we reach net zero, obviously it means turning away from fossil fuel, that's basic, and therefore increasing renewable. The difficulty is that currently, and that's what you see in the slide, fossil fuel, coal and natural gas and oil provide more than half the flexibility the power system need. So if we get rid of this fossil fuel, we need to increase other sources of flexibility. And the point I'd like to attract your attention to is the blue and gray area on the right, which in 2020 are very small, but which will reach almost half or more than half the flexibility resources in the system by 2050. And these are batteries, all sizes of batteries, and demand response. And you will see that their share of flexibility increased dramatically. And that's not all, because here it's in percentage, but also increasing the share of renewable in the systems means that we need more flexibility as a whole, and that the whole flexibility need increased fourfold, while the share of demand response needed also increased dramatically. So if we zoom into that gray area of demand response, here is in gigawatt what happens to demand response in just 10 years, that 2030, if we want to reach net zero. And so it increases tenfold. And another important point to notice is that building account for around half of it. And that is extremely important because currently demand response will be mostly about industry, very large building, But if buildings are to account for half demand response, it means smaller buildings are needed, residential buildings are needed. And that explains why we need them to be smart, to be data-driven, because it means aggregating very tiny sources of demand response to make sure that these buildings are used. And that's the general direction where the system is going. We used to have unidirectional flows going down from the major thermal power plants to the consumers. And in the future, we will have, thanks to digital technology, multi-directional, highly integrated energy system where every part of the system can provide flexibility. It can be the car, it can be the buildings, it will be buildings for half of it, half of demand response. And all this means smart, because you won't be able to manage yourself your own building, checking the market price and adapting your AC while looking at market price. All this must be automated, must be able to talk with the system, must be able to extract data from the system and to react to it. So that's why you are heading to these smart buildings, because buildings are needed to provide flexibility, and we need digitalization and smart building to provide flexibility in an efficient way that does not mean every consumer has to turn into an energy trader. So now that's what we need. And where are we going? If we look at investment, and that's investment in venture capital in energy efficiency startup, we see that investments are growing up in this field. And we see that energy as a service in building is increasing. So building is an important share of venture capital investment in energy efficiency, and it's growing. So that's good news. But that's perhaps not enough when we consider how big is building as a whole for the grid. Building is a big topic for the grid. Currently, it's 28% of energy-related emission. Demand is rising from 20 to 50, and most of the increase is in emerging economies. So that's a massive growth for the power system that we need to ramp up to supply this demand. And it will be a huge challenge for power systems. But luckily, potential saving exists, and just smart control could enable an energy efficiency gain, reducing to 350 megaton of CO2 by 2050. And if we zoom to air conditioning, we see exactly the same trend. It represents a large part of energy consumption currently. It becomes even bigger by 2050, and with just China, India, and Indonesia contributing for over more than half households with ACs. But again, potential saving exists. Improvement of energy efficiency equipment could save 2,000 terawatt hours. So that's again is essential for the grid, because if we want the grid to accommodate successfully all this extra energy demand while getting the flexibility it needs, it means that smart buildings are fully needed and are an urgent things for grid, and especially for grid that are already under constraint to get. So that is the main message. Electric systems are transforming, more flexibility is needed, and we need data for that. And I hope I have convinced you that there are huge benefits to it, to making the system more responsive, to support the carbon emission, so also to minimize system cost as the consumption grows. But now what we must consider is that we need the right policy to get to this point and to succeed in this policy. And here what I must insist on is that the right policies are not just about market or just about standard. You need to have policies in every direction. For a good digital system, you need a good platform and data management procedure. You need extra good cyber security and data protection framework. And with this question of data protection, you need stakeholder awareness. It's not just about making the data safe, it's also making the consumer confident that the data is safe. You need to value this flexibility so that consumers are motivated to give the flexibility. You need to value it especially for disadvantaged groups and communities that may not have the means to invest or even to understand how they could digitalize and provide flexibility. That goes with the question of skill and training, both for consumer and for workers in the industry. You need to consider recycling and the efficient and also the efficiency of the tools you will be using of all the processor data centers and so on. And you need financing, especially for innovation. And you need to consider all this direction. And if you miss one of these needs, you will be losing time in digitalization. So as you see, it's a very ambitious program. Some of our future upcoming speaker will help you see how it can be done concretely on the ground. Another thing, at the IEA, it's also a topic on which we are working, mainly the Trident project, which is a project that exactly try to look at all these dimensions of creating the digital transition. It's turned mostly toward emerging economies, and it has the interesting feature of being coupled with pilots led by UNEP, so that we're doing both desk analysis and pilots. And that's a project on which we are always keen to engage with people working in these topics of digitalization. So that's also a call for people interested in either following or discussing with us on this project. And another good platform to go for more information on this topic is the ISGAN, which is a smart grid network, where again you will find many resources on smart grid in all countries and how to lead this digital transition.